Hello, hello, hello. Good morning, everyone. Make a shout out all the subscribers and followers of this channel. And please don't forget to like, share, and subscribe. And if you have questions, please leave your comment at the comment section below. Okay, today we are going to study properties of parallel lines. We have here some of the objectives. I can prove theorems about parallel lines and can use properties of parallel lines to find angle measures. So remember the key vocabulary: the same side interior angles postulate, alternate interior angles theorem, corresponding angles theorem, and alternate interior angles theorem. Okay, so we have here the look at the map of street in Clearwater, Florida. Nicholson Street and the parallel pairs of angles appear to be congruent. Now, okay. So you identify several pairs of angles that appear congruent. So you already know the relation between vertical angles. So in this lesson, we'll explore the relationship between the angles learned previously when they are formed by parallel lines and transversal. Okay, so we have your properties of our lines. So the special angle pairs formed by parallel lines and transversal are congruent, supplementary, or both. Okay, so we have here postulate 3 does 1, the same side interior angles postulate. It says if a transversal intersects two parallel lines, then the same side interior angles are supplementary. Okay, so we have here angle 4 plus the measure of angle 5 is 180. Same also the measure of angle 3 plus the measure of angle 6, that is 180. So this is same side interior angle postulate. For example, we have the measure of angle 3 is 55, which angle is supplementary to angle 3. Of course, uh, the angle that is supplementary is angle 2. No? Because if it is 55, then this must be 180 minus 55. Okay, so we have 5, and this will be 7 minus 5 is 2, 125. So this is 125, and this is supplementary to angle 3. Okay, of course, I know, and you will know. All right. Then we have also another properties. This is same side interior theorem to prove the angles are congruent. So if the transversals intersects two parallel lines, then the alternate interior angles are congruent. So we have here angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. So this is alternate interior angle theorem. Another theorem is the corresponding angles theorem. So if a transversal intersect two parallel lines, then the corresponding angles are congruent. So like this one, we have angle 1 and angle 5, no, are congruent. Angle 2 and angle 6, angle 4 and angle 5. So this is corresponding angle theorem. It corresponds, no, to one another. So, and also we have alternate. So please don't forget to memorize all these things. And so you will be needing this. Okay. So for example, we have proof of alternate interior theorem. So we have E here, or line E is parallel to line M, and we'll prove that angle 4 is congruent to angle 6. Okay, so statement, line L is parallel to line M, that is of course given. Measure angle 3 plus measure angle 4 is 180 degrees, so that is supplementary angles. Yes, no, it's supplementary angles. And measure angles 3 plus measure angles 180, of course, that is same side interior angles postulate. Measure angle 4 plus measure angle 3 plus measure angle 4 is equals to measure angle 3 plus measure angle 6. That is transitive property of equality. And measure angle 4 is equal to measure angle 6, that's subtraction property of equality, of course. Therefore, we could say that measure angle or angle 4 is congruent to angle 6. That is true definition of congruence. Okay, so we have here problem number 2. A is parallel to B. So prove that angle 1 and angle 3 are supplementary. So we have here measure angle 1. They are supplementary because they are alternate interior angle. No? Or corresponding. So because of corresponding, no, not alternate, but corresponding theorem. Corresponding angle theorem. Okay, that's theorem. That's the reason that they are supplementary. Prove that angle 1 is congruent to angle 7. Of course, this one is the alternate, no? So that they are congruent through alternate in exterior angle. Alternate exterior angle, okay? Exterior. Okay, so they are congruent. Theorem. Then we have here, okay, so this is what we're talking about. So, in the previous problem, so the angles alternate. So if the transversal and these two parallel lines, then the alternate exterior angles are congruent. So, I, I am correct. All right, so here, if you know the measure of one angles formed by parallel lines and transversal, you can use theorems and postulates to find the measures of the other angle. So, for example, what are the measures of angle 3 and angle 4? So justify your answer. Angle 3 and angle 4, these are uh, alternate interior angles. No? So alternate interior, and they carry the same measurements. Of course, if we are going to look at here, angle 8 is also equals to. So what would be the angle 1? So angle 8 is equals to 105 first. Yes, because it's here, the same here. And of course, angle 7 is 105. What about angle 6? Okay, angle 6, the same with angle, so this is also 105. What about angle 5? So since this one is the same, no, for angle 105, so angle 5 is also 105, see? And angle 2, of course, 105, 180 minus 105. Okay, so we got here, we have 10, 5, then 7. Oh, this is 75. Okay, 75 plus 105 is 180. So measure angle 2 is 75. Of course, 71 is also the measure of angle 1. Get it? Easy. Okay, so what is the value of y? All right. So you can see here, okay, so this is y, of course. If you are going to look at here, this one, no, is this smaller, no? So if you are going to divide this, okay, so what do you think is the answer? Okay, if this is 80, this is 100, no? And this one is the same as this. So if this is 100, that means y plus 40 equals 100. Okay, so y is equals to 100 minus 40. That is equals to 60. So therefore, y is equals to 60. Yeah, 60 plus 40 is 100 because this should be 180. And 100 plus 80 is 180. And they have the same measure as the angle y and the 40 degrees angle. Oh, yeah. Okay, now the figure below, what are the values of x and y? So what are the measures of the four angles and the figure? So first, we need to find no the answer for it. So let's do y3y plus y plus 20 is equals to 180. Now, why 180? Because the total measure of this trapezoid, oh yes, 360 degrees because it's quadrilaterals, no? And the quadrilaterals are in sides, or the total measures of their angles is equals to 300, 360 degrees, or the 180 plus 180 is total, no? Then 3 plus 1 is 4. 4y is equals to 180 minus 20. So 4y is equals to 160 divided by 4. Okay, y is equals to 40. Right. Now, if this is 40, 40 times y, of course, this is 120 degrees. And we have here 40 plus this is 60 degrees. Yeah, I'm correct again. Okay, so y is 40. So this is 40. Okay, next. Let's go to the next. 2x plus x minus 12 is equals to 118. Okay, so 3x is equals to 180 plus 12. Okay, so 3x is equals to uh 192, no? So 192 divided by 3, we got 6 times 3 is 18. Then we have 12. Okay, 12 divided by 3 is 4, so get minus 12, so that is equals to 0. That means 12 times 2, am I correct? 64 times 2. So 64 plus 64 is 128. Okay, this is 128. And then for x, we have 64. 64 minus 12, that is equals to 4 minus 2 is 252. And 52 plus 128 is 108. Oh, correct. Okay.